All right, let's move on to actually solving some length problems, lengths of curves, arc lengths. So the arc length for y equals f of x is what we did in the first video, just doing the proof, bringing it on up. So as long as we let f have a continuous first derivative on the interval from a to b closed, of course. You need that to be true, at least on the interval. Don't worry, you won't see anything that won't work like that, I don't think. The length of the curve from x1, y1 to x2, y2, oops, I'm sorry, we're in calculus, a comma f of a to b comma of f of b is, and there it is, the arc length. The integral from a to b of the square root of 1 plus the derivative squared dx. So let's try a problem. Let's find the length of the curve, f of x, which is equal to x to the 3 halves, between x equals 0 and x equals 4. Get used to seeing those 3 halves powers. Yeah, it just happens a lot because these have to be cooked up. I like that term, cooked up. A lot of the things we don't really have the techniques to integrate yet. So our arc length, or the length of the curve, is going to be the integral from 0 to 4 of the square root of 1 plus our derivative squared dx, which means we have to take our original function that we're trying to find the length of the curve on. We got to find its derivative. So f prime of x is equal to 3 halves x to the 1 half power. Cool. Let's pop it in. And again, oh look, what's 1 half times 2? 1, so we can do the gosh darn problem. So let's tackle this now. So from 0 to 4, the square root of 1 plus 3 halves squared is 9 fourths. X to the 1 half power squared is just going to become x dx. And now we can see a quick, simple u sub, and we'll get this thing done. So let's let u equal the radicand, all the stuff underneath the square root, and we get that du is just equal to 3. It's just 9 fourths dx. And we want to solve for that dx, so let's multiply the reciprocal on over, and we can say that dx is equal to 4/9 du. Cool, let's go. Integral, let's leave the bounds out. We'll deal with that in a second. So instead of writing in 1 plus 9 fourths x, we put in our u. I don't think I needed that big of a square root. You know what I mean? Don't think so. So instead of dx, we're going to write 4/9 du. So let's take that 4/9, put it out to the front, and just put in our du. Well, now we need to go through and solve. We need to get our new bounds, huh? Because this is all for x equals. We need for u equals. So when x is equal to 4, we're going to get that u is equal to 1 plus 9 fourths times 4. Those just cancel, and we get that u is equal to 10. Next, we have a 0. Oh, zeros are the best. Therefore, u is equal to 1. I'm just writing it. Use 1. Stay consistent. There we go. And now we're ready to go. We no longer have to go back into terms of x's. We can stay in terms of u. So this is u to the 1 half power du. So let's add 1 to that exponent. We get u to the 3 halves. And now let's multiply by its reciprocal. And then we're going to take our integral from 1 to 10. Now these numbers aren't going to turn out beautiful or anything like that. We're going to get 8 over 27 times 10 to the 3 halves power minus 1 to the 3 halves power. But I would just clean this up and just put it this way, because 1 raised to any power, right? It's just 1. And there's our solution. Without a calculator, I mean, we're not gonna know exactly what it is. I mean, it's approximately 9.1 units. But this gave us the length of a curve. So don't expect your answers to turn out to be like 7 or 4. I mean, sometimes we can get lucky and get clean answers, but typically not so much. All right. Cool. See you in the next one.